All right, folks, it's Bass Action back in action here. In this video, we are going to talk through the problems from the warm-up. So at this point, you should already have done your videos for the notes and maybe tried these to see what you could do. And if you're stuck, these are your explanations for them. All right, you'll notice that I do have it all filled out because I'm just working through the explanations and helping you see how I got to the answers I did. All right, on the first ones, I was looking for the x and the y-intercepts. Remember, the x and y-intercepts, we're just going to let x or y equal 0 as appropriate. So if I want the y-intercept, I can let x equal 0, and that's pretty easy because then these two pieces just drop out. So I get a negative 13, and remember, intercepts are always written as ordered pairs. To do the x-intercepts, though, because I'm specifically trying to do this without a calculator, I'm going to use the completing the square strategy. So I'm going to let my y equal 0. When I did that, I kicked my 13 over to the left-hand side so I could keep this x squared positive. I wrote my two blanks. This 25/4, I took my 5 and I divided by 2, and I squared it. So 5/2 squared is 25/4, and then I balanced. Now remember, this side is going to immediately factor into this x plus 5/2 quantity squared. This side I'm going to have to get common denominators, so I like to write the 4/4, so I can see I'm going to have a 52 here, plus the 25 gives me my 77. When I take the square root of each side, that's going to cancel out this whole parentheses, and I'm going to do the square root of the top and the square root of the bottom. Now you can see when I rewrote the next step, I like to write the x on the other side, but what I was really doing was taking this 5/2 and moving it over here to the left as a negative 5/2, and then I of course had my plus or minus there. So that's how I got this, and then I wrote it as a nice ordered pair. On the next one, again, same deal. If I was looking for the y-intercept, I let x equal 0. These dropped out so I could grab the constant. On the x-intercepts, what I did was I factored out that -3 first before I put in my blanks. And then the 16 was the 8 divided by 2 squared. But when I balanced this one was a little bit trickier. When I balanced this, I had to take the 16 times the -3 to get the -48 to properly balance. Then, before I could take the square root of this side, I had to divide by that -3, and I got this weird looking fraction here. And then, when I did my square root, that of course was going to clear up this nice x minus 4 there, but this fraction here with this radical needed to be rationalized, so I got that final answer by multiplying the top and the bottom by a radical 3. Okay, now on this little problem solving here, hopefully you've tried this with a friend, we were looking for which pair of equations might represent this graph. And honestly, before you jump into the problems over here, you want to look and think about all the things you might know about lines before you try to start looking at this. So things that we want to think about. We know that one of our lines should have a positive slope and have a positive y-intercept, and the other line should have a negative slope and both a negative y-intercept and x-intercept. So one line is going to have a positive and a negative on the y and the x, but the other line is going to have a negative slope and the intercepts are going to be negative. The other thing is that since they're perpendicular, their slopes should be opposite reciprocals. So any pair of equations that we choose need to meet all three of these. So I like to look for the perpendicular slopes first. So when for example, on A, when I looked at them, I could immediately see that my slopes were not going to be opposite reciprocals, so it immediately got rejected. On the next one, when I was thinking about intercepts, because the intercepts are pretty easy to grab here, I notice that their intercepts, because this equals 0, they're going to have intercepts at 0, 0. So there's no way this could be my lines. Here again, I mentally calculated my slopes, saw they were not perpendicular, so I threw that one out. Here, I calculated my slopes, and once I got my slopes to check out, then I could also check my intercepts and make sure those made sense. And I just did it mentally. Remember, you can cover up the y and get the x-intercept. You can cover up the x and get the y-intercept and check those. So that worked, and I did the same thing on E. Okay. Obviously, I'm not going to give you a problem like this on the test because that would take too long, but there's lots of little skills in critical thinking and problem solving that I would want you to be able to piece together and know that those are all tools and things you could understand about a line. And then on the last one, working through some distance, midpoint, and slope with fractions. I want you to see how we could write all this out. So if I was doing my distance formula, remember we subtract the x values and we subtract the y values, but I like to just flip that to the negative if I can. Since these had the same denominator, they were going to be pretty easy to pull together. So my -5 minus my -5 halves and my -7 halves, when I subtract those and square, is going to be 144 over 4 and then 256 over 4 here. Now, there's often a big temptation to try to maybe convert these to decimals, and I would not do that. This one actually turns out really nice, but it doesn't always. So I would say keep those as those fractions as long as possible. When we get to here, we can see, oh, sure enough, it is going to reduce and give us a nice whole number that we could simplify. On my next one, for midpoint, remember midpoint is an average. So since midpoint's an average, we're going to add those coordinates. So I'm going to add these together. My -5 halves plus my 7 halves is actually going to give me a 2 over 2. So now I've got a 2 over 2, which is just a 1. Okay, so remember this is really, if this is a 2 over 2, that's now going to actually be a 1, and my 1 over 2 is my 1/2. On my next one, same thing, my 7 halves minus my 9 halves gives me a -2 over 2, which is a -1, so there's my -1/2. Then on my last one with my slope, remember that has to be rise over run, the change in the y values, so I needed to do the y values, over the change in the x values. And just like before, if I have my 7 halves and my 9 halves, that's going to give me my 16 halves. So this is going to give me 16 halves. And then in the bottom, I'm going to have a -5 halves minus 7 halves. So if you're, that's going to give you a -12 halves. So what I want you to see here is that my 16 halves over my -12 halves is going to be this -16 over 12. So you'll notice that here I went straight from here to here and I had marked off these 2's. That's because if I have a denominator of 2 in the numerator and a denominator of 2 in the denominator, that sounds kind of crazy, I can just automatically know those are going to cancel out. So I didn't actually write these out, I jumped straight to here. And then I just reduced my fraction to a -4/3.